We okay so far with everything on the board right now? So the next question is, so how do we find the loop invariant? The answer is it's out of the scope of this class. Good thing, right? Okay. Finding a loop invariant is difficult. Okay, so in other words, you guys will never be expected to figure out a loop invariant in this class. It does not mean that I cannot give you a suspicion of, hey, maybe the loop invariant is this. Can you check and see whether it will work out? Because that's an entirely different question. Okay, asking you to derive a loop invariant is very difficult. But if I tell you and say, I suspect the loop invariant is blah, can you prove to me that it will make everything work out? That we can do. Okay. However, given a suspicion, we can prove whether a condition is a loop invariant or not. Okay, so let's think about this, just for this specific case. Let me think about it. Let us suspect that the loop invariant is post 3 is simply to say x is less than or equal to 3. It's a suspicion. It is not confirmed. It's just, oh, somebody told me, Tech, why don't you try this and see if it works out? Okay? So here, what we want to do is to plug this in and see whether it will work out or not. Okay? Now we can just plug this in and see if it works out. The one part that makes that will really make a difference is this part here. So I will just copy and paste it. Okay. So from here, I can actually just plug it in, can't I? In other words, when I perform the substitution operation, here inside the substitution operation, when I see post 3, I would just say that let me plug in whatever that someone told me about post 3 and see if it will work out. So I put x is less than or equal to 3 here. The rest are exactly the same. Is that okay? All I did in this case is to replace the previously unknown post 3 with the suspicion that post 3 is as simple as x is less than or equal to 3. Because if this substitution operation works out, based on this assumption, I actually get x is less than or equal to 3 back as a result of the derivation. It confirms the suspicion was correct. Okay? So we'll go ahead and actually do the substitution now that we have the entire precondition specified. So we replace all occurrences of x with x minus 1. So the first condition is x minus 1 is less than 3. And the other part is x minus 3 equals to 0. Or x minus 1 is less than or equal to 3. Are we okay so far? All I did here is to locate an x, replace it with x minus 1, locate an x, replace it with x minus 1, locate an x, and replace it with x minus 1. Okay? Basically, the substitution operation. Are we okay? All right. Tech, it doesn't look like the assumption at all. I mean, this junk here, this entire thing, is the same as that? I don't think so. Well, let's see if we can simplify things a little bit. Just because it does not look like it doesn't mean it is not that. It's just that can we make certain changes and make derivations so that they are exactly the same. So the next step is to do some simplifications. When I say that x minus 1 is less than 3, now let us assume x is an integer, okay? Because without that assumption, it does not work. if I know ahead of time that x is an integer, okay, let's just do one more step of derivation before we make that assumption. Don't you think to say that x minus 1 is less than 3 is to say that x is less than 4? We just add 1 to both sides, and we get rid of the minus 1 on one side. The other one is to say that x equals 1. Okay, because if you look at this condition here, it is the same as the same as saying x equals 1. And then the other part is to say x is less than or equal to 4. Right? Because we just add 1 to both sides and then we get that. Great. Now let's see if we can actually change it back to the original form because of that. Well, we can actually do something on top of that at this point. We can simplify certain things already. Let's look at the disjunction here. Look at the or here. Is there a way to simplify x equals 1 or x is less than or equal to 4? Is one of the components redundant and it really does not need to be there? Yeah. X equals 1, right? Yeah. We can get rid of x equals 1 because when you are taking a disjunction, it is taking the union of two number sets. So in this case, one set is basically a single element. The other one is huge and it includes the first one. When you're taking the union, you take the larger one. So in this case, we take the larger one and we can discard the smaller one. Okay, we can do just that simplification here. Can we simplify here a little bit too? Up here. If I say x is less than 4 and x is less than or equal to 4, which one can go away? Less than or equal to 4 can go away. Okay, now why is that the case? I mean, when we take the or, we get rid of the specific one. When we take an and, we get rid of the general one. Because the and is a conjunction. A conjunction is the same as taking the intersection of two sets, right? Now, if you think about the intersection, this is a subset of this one. So the intersection is only the subset. So that's why we can throw away the superset and only keep the subset. Is that making any sense? When you have a conjunction, you keep the more restrictive one. When you have a disjunction or, you take the more general one. But you can only do that trick when one is a superset of the other one. One has to completely contain the other one. Do you guys still remember those set operations from school? Yeah? No? Okay. Yep. Oh, you still remember? Okay, very good. Okay, set operations are actually very important in computer science, because we kind of need to know these concepts in order to know how to simplify equations like this. So it boils down to x is less than 4, and someone's going to say, but Tech, that's wrong. See, this one is x is less than or equal to 3. This one is x is less than 4. They are not the same. Right? Because I can find certain values less than 4, like 3.5, that is not less than or equal to 3. Well, that is true unless I tell you that x is an integer. Now, if I tell you that x is an integer, then saying that x has to be less than 4 is the same as saying x is less than or equal to 3, because 3 is the largest integer that is less than 4. Is that making any sense? Okay, so we'll just do that one additional simplification. X is less than or equal to 3. Wow, it works out. The assumption that post 3 is x is less than or equal to 3, going through all this derivation, actually proves that it is, which is good. Okay, this means that the loop invariant is, in fact, x is less than or equal to 3. Okay. Now I'm pretty sure, in one of my other classes, somebody asked right away after this, mess here and said, yeah, but this has nothing to do with programming. It has nothing to do with, programming at all, because, all this simplification stuff, should be taught in a math class. And it has nothing to do with programming at all. What do you guys think?
It has to do with it, because how else would you define the loop? You don't use all these numbers.
Well, you could, okay, but I'm talking about just the derivation. I'm just talking about the part that goes from this big old mess down to this little simple thing here.
Well, that's what you need to
You
code.
want to write all that stuff out, right?
Right.
Yeah, you need the answer.
Well, what is the problem of writing all this stuff out? I know your point, okay, and you are correct, but I just want to kind of spell
You
out the
wouldn't
rest
use
of
that in the code.
I could use that in the code. I mean, I can, in a conditional statement or a loop, instead of saying this, I could say this, the compiler will take it. It's not syntactically wrong. And it is not even logically wrong. They're equivalent.
But it's so long.
It is so long and it is confusing.
All right.
Okay? The same person who wrote this condition 2 months ago will not be able to come back and say, oh, but what exactly does that mean? Okay? When do I get out of the loop? When that condition is false, but what does that mean? I don't know. But when you look at this, you say, oh, we get out of the loop when x is greater than 3. Okay? Which is actually not the case here, but the whole point is this being the same as this doesn't mean that you should use this one in programming. You should be using the simplified one whenever you can. Now, we can also kind of go back in time a little bit and think about the multi-branch conditional statements. Do you still remember the multi-branch conditional statements? If condition 1, then blah, blah, blah. Else if condition 2, then else if condition 3, blah, blah, blah. Did I mention anything about dead branches?
Yeah.
Okay? If the conditions of a multi-branch conditional statement, if they're all like this, can you just look at the code and say, oh, this doesn't make any sense because this condition is already including these other conditions here, and these will have to be dead branches. It would not be obvious, right? Because if all the conditions are like this, it becomes really hard for a person to look at that code and figure out, okay, this condition is already including all the other ones, and the other ones, all the branches of the other ones will be dead branches. So that's why in programming, it is actually important to understand how to simplify Boolean expressions. Because once you can simplify or at least show that this Boolean expression is the same as the other one, it really helps in terms of debugging the logic of the program. Okay? Now, whether you can do it in one step or do it quickly, it depends on experience, exposure and stuff like that, which is not the point that I was trying to make. The point that I was trying to make was that it is important. In this class, I would not expect people to be able to do it quickly like this, but at least you should understand how it is done. Okay? Okay, well, if post 3 is working out, that's good, because I can now get to post 4, which is actually the whole objective of the whole thing is post 4. So post 4, if I just copy and paste from before, is this thing here. So I'll just go ahead and paste it. But now that we know post 3 is x is just less than or equal to 3, let's see if we can simplify a little bit. So x is greater than or equal to 3 is still true, but it's on the outside of the or. We have x equals to 0, or x is less than or equal to 3. And as before, we can simplify the disjunction to just x is less than or equal to 3. Can we simplify a little bit here? X is greater than or equal to 3, and x is less than or equal to 3. What is that saying? X equals 3. Very good. So all this is saying is x just equals to 3, and we're done. Okay? Now, obviously, we could have traced this algorithm and prove that x equals to 3 in just no time. On the other hand, what if I give you an algorithm where, okay, let me just copy and paste it here.